This is the third video on Mathematica. In this video, I'm going to talk about commands. We'll start with some basic commands, and then we'll go into some more advanced commands like the manipulate and the do command. In Mathematica, commands all start with an uppercase letter, and then the command is in brackets for the most part. And there's some where it gets a little dicey whether it's a command or not. So for example, one of the most basic commands that we're going to use all the time is to plot something. So the command to plot is the word plot. And so for example, if I come here, get into my notebook, and I type plot, it's uppercase P, L-O-T, and then the commands are always followed by brackets. So bracket, not a parentheses, bracket, and then whatever the command is. And if you recall from the previous video, if you go to this double caret down, it will show you how to actually fill in these commands. So I'll actually do that. So there's the syntax for the plot command. So for example, if I wanted to do the square root, that's Control 2 for the square root of x. And we're going to make x go from, I don't know, let's say 1 to 15. And then we'll plot that. There is the plot of that. Notice that this plot, the axes are not my x and y axis. The x and the y values are both starting at 1, and we can fix that by adding a plot range command. But here, even though it's a command, this one is not a bracket, it's an arrow afterwards. That's because it's an option for plot, it's part of the plot command, and it doesn't ever stand by itself. You can't just do plot range by itself. So if I do plot range -2 to 14, that's my x, and we'll do another set of braces. Remember that a brace is for a list, so we've got the list of the x values, -2 to 14, and then a brace for the y values, which I'll make go from -1 to 4, and that also has to be part of the brace. And so these two outside braces, that whole big list, and then there's interior lists. And so now when I plot it, there you can see I've now created a plot range, which is a command in a sense. All right, there are tons and tons of commands. I can't tell you them all because there's too many of them. Some of the basic ones that you're going to need to know how to do. Solve is a great command. So solve will actually solve an equation. So solve, S-O-L-V-E, and you can see it comes up here. We can click on that. And it'll tell us expression and variables, not really helpful here. So if I click on that, it doesn't tell me much. Solve, you're going to give it some equation that needs to be solved. So do a simple one from the quadratic formula days. Ooh, let's actually make a nice square. So that's Control 6, x squared plus 3x plus 1. That's obviously not factorable, so it's one of the reasons we use the solve command. And this gets a double equals. Single equals is a replacement. This is not a replacement. We're trying to show equivalency here. Equals 0. So that is, we're not trying to replace x squared plus 3x plus 1 with 0. We're trying to say that these two are equivalent. And then it's going to ask me what the variable is. Because in this case, there's only one letter, but sometimes there could be more than one. And I have to tell it which one is the variable. In this case, it's x. And Shift Enter. And you can see there it has solved it. And it just basically used the quadratic formula. Another one you could do is just factor. Won't come up a whole lot this year, but you might want to factor something. So same thing, x squared plus 4x plus 3. Now this time we don't need an equals. And there it is, it's factoring. Boy, wouldn't this have been nice if we had it in Algebra 2. There's lots of commands out there. And I'll show you a way to see some of these in a second. Now, remember, uppercase to begin a command, brackets to define the command. There is a second way of presenting this. Instead of doing solve brackets, you can, if you want, write something down and then put the command at the end. So for example, I could say x squared plus 4x plus 3, and then // factor. This // command is a shortcut way of doing a command. Now, this is nice. Again, it's faster. but it would have not have helped with my plot command up here, because then I can't actually tell it the plot range and where the x values are, etc. So the // is nice if it's something quick, but not if you have something like this that's complicated. One / that you will find yourself using all the time is /n. /n gives you the numerical approximation of whatever you've done. So for example, if I type the square root of 3 and do Shift Enter, it's just going to say it's the square root of 3. That's the most exact answer, and Mathematica is always going to try and give me an exact answer. But if I do the square root of 3 /n, it's going to give me a numerical answer. Now, the n command also works. N bracket square root of 3 also would give you that. So you could use either the brackets or the //. The // is useful just when it's a simple single command at the very end. Here are a couple of more complex commands that you're going to want to see. The first is manipulate. The manipulate command allows you to change something on the fly, specifically related to plots. So for example, let's say I wanted to plot x squared between, let's say, -2 and 2, and we want to actually draw it between -2 and 2. So if I just plotted x squared, boom, you get the whole plot just at once. But I want to actually show this plot drawing. And the way I do that is with a manipulate command. And the manipulate means that we're going to change one of the variables with a slider over time. If I wrote manipulate, and I want the same command, so I'm just going to copy this. Copy. So bracket the plot command. Now you see there's a little caret here, meaning there's some information missing, too few arguments given. And so now I have to tell it what I want to manipulate. So instead of going from -2 up to 2, I'm just going to go from -2 up to a, and then I'm going to tell it that a is going from -2 to 2. And so what's going to happen is the manipulate command is saying keep changing a, and there's going to be a little slider bar that appears that's going to make a change from -2 to 2. And so it's going to plot -2 to -2, -2 to -1.9, and you're going to see this function growing. Now, it's not going to work. And you can see here when I run it, something seems to have gone wrong, even though everything makes sense, except actually manipulate doesn't like when x is going from -2 to -2. I'm not sure why that is. So I'm going to make this just a little bit bigger than -2. So -2 plus, I don't know, 0.0001. And now it'll work. I don't know why that is. And there is my plot. So this is -2. You can see -2 to -2 effectively. And that's what the graph looks like. And here's my slider A. We could rename this to something better. And as we move the slider, my function appears. Now this is not great because you see that the plot is changing constantly, which is annoying. So I'm going to go back and add my plot range. So if you recall, here's my command for plot range. And I'm just copying that just to make my life easier. Oops, down to the manipulate one. In the plot command. And I'm going to make this go from -2 to 2 for x, and y we'll just keep it at, no, that's fine, -1 to 4 is good. And now when I do it, the plot range, that is the graph paper that I'm using effectively, is not going to change. So when I run this, what you see here is nothing except for this little dot right there. That's my -2 to -2 plus 0.000001. And as I shift A, what you're seeing is it's constantly reevaluating this function, changing A the whole time. And so it appears as if this graph is growing. Now you'll notice this plus sign up here. This actually makes it a animation. So if I click play, it will move in the positive direction, and that's this arrow here means move forward. If I click on the arrow, it'll move backwards. Click again, it'll move both directions. So it'll move all the way up to one end and then sort of work its way back. And then these two will make it go faster or slower. So if I go faster here, you'll see it just bouncing back and forth. If I pause this, then the plus and the minus are just steps. So I can step forward. And you'll see here the steps are by 0.2. You can set that in your manipulate command. So I could say here, go from -2 to 2, and I'll add another comma and then say with a step size of 0.1. And now when I step, they're by 0.1s. And you can change that to be whatever you want. And if you're going from, let's say, 0 to 10,000, you probably don't want to step every 1. You might want to step every 1,000 or every 500, etc. Similar to the manipulate command is the do command. The do command is kind of the same thing as a manipulate, except there's no particular output. So it's not plotting anything. It's just doing something. It's a for next loop effectively. So for example, I could say do, I'm going to let x sub n, the sub is control and then the underscore, sub n, and I'm going to let that equal to n squared. And I'm going to do from n going from 1 to 10. And when I do shift enter, it doesn't appear as anything's happened. But now if I say, hey, what's x sub 3, it's going to tell me that it's 9. So this do command has created this array x sub 1 through 10. How can you see this? One more command and then I'll be done. And that's the table command. Now the only bad thing about the table command is it doesn't create a table, it creates an array. So if I said table and then exactly the same thing up here without the equal sign. So I'm going to say, copy this, paste it in here, but we're going to get rid of the n squared. I'm just going to say, hey, tell me what is x sub n going from 1 to 10. It's going to create this table, but it's an array. If you want it in table form, then there's another command called, shockingly, table form. Now this is just going to put it in a single table. If you want to have 2 lines, for example, you want to have a column and a header, etc., you can do that. So instead of just saying what's x table x sub n, you could do, for example, n comma x sub n in an array. And I can create a table header and do other things like that. But I'm not going to show you all those because they're all in the help file. And here's a last command. I keep saying last, but here's another one. It's just the question mark. So if you say question mark table form, shift enter, it will give you the help file. And if I click this down arrow, it'll show me what it is. And there's the documentation, which will actually open up on my other screen. So I'll bring it here so you can see it. Here's table form, and it shows you how to do it. The last thing, this really is the last thing. I'm going to go to help, and this is the documentation center. And you can see all the different possibilities that we have here. So for example, symbolic and numeric computation. And I'm going to click on this, and Mathematica functions. Every single thing you see here, every one of these is a command. And there's a lot of them. These are things that are well beyond even my knowledge. So I know how to conjugate something. I know how to find the real, the imaginary part. But what is the Mobius mu number of something? Not quite sure. And if you go into any command, so for example, the round command, and it gives it to you, when you get down to the bottom, there will be a C also, and there's going to be a ton more commands. So when you're thinking about commands, really, 2 things to remember. Start with an uppercase letter, brackets, and then beyond that, it's just out there exploring. Start trying things. Plotting is easy, solving is easy, factoring, manipulating, and then start looking for things that you want to do. Look in the help file and see if there's a command that does it, or maybe a command similar to what you want, and just play and add to your repertoire.